Hello Legacy Sabers, and this is Miss Marsh speaking. Today we're going to look at solving equations with variables on both sides. Your learning goals for this particular video is I can solve variables on both sides. That should be with. Solve with variables on both sides. Goodness. And I can identify equations that have infinitely many solutions or no solution. So, how do you solve equations with variables on both sides? What you're going to want to do, you're going to use the distributive property to remove any grouping symbols, aka parentheses. You're going to clean up your fractions by multiplying by the least common denominator. And then you're going to combine like terms, if you have any. Get the variable terms on one side, constants on the other. Solve for the variable. Do addition or subtraction, then multiplication or division. So the big thing is we're going to have x's on two sides. So look how I have 5x plus 2 equals 2x plus 14. I need to get everybody to the same side. So x's on one side, numbers on the other. So very first thing I'm going to do, I'm going to move the x's to the other side. I like to keep my x positive. Here's the reason. It takes a lot longer if I make my x negative. So I'm going to actually subtract 2x from both sides. I could have subtracted 5x. I would get the same answer ultimately. So 5x minus 2x, that's 3x. And I'm going to have plus 2 there. Those cancel out, and I'm left with 14. 3x plus 2 equals 14. I got to get my numbers away from my x. So I'm going to subtract 2. And we get 3x equals, because those cancel. 14 minus 2 is 12. Let's divide by 3 quick. So I get x equals 4. Not too bad, right? Basically what it is making sure everybody gets to their own side. What about one with the grouping symbols? Basically means I got parentheses in this, and I gotta get rid of them. So let's distribute this 2 in. So I'll get 2 times 5, which is 10x. And 2 times negative 1 is negative 2. Let's distribute the 3 in on that side. So that would be 3x, because 3 times x, right? And then 3 times 11 is 33. Let's get the x's together. So I'm going to subtract 3x. 10x minus 3x, that's 7x. And I saw this negative 2. He's just going to kind of come along for the ride. That's canceled out. And I'm left with 33. Let's get that negative 2 to the other side. So I'm going to do the opposite of subtraction, which is addition. So I'm going to add 2 to both sides. Left with 7x. Those are going to cancel. 33 plus 2, well, that's 35. And now it becomes a really easy problem, right? Divide by 7. X equals just 5. Not too bad, right? It's pretty easy. It just kind of depends on how you look at it. Let's take a look at this one. Very first thing I notice, I have grouping symbols, parentheses. So let's take care of that. So I'm going to multiply that 2 in. So I'm going to have on this side 10x plus 12. 2 times 5x is 10x, and 2 times 6 is 12. So I have 10x plus 12 equals 10x plus 12. Subtract my 10x. Well, that's weird, kind of cancels out. Left with 12, and that cancels. I get 12 equals 12. That's kind of strange. What are we going to do with that? Do I have a solution? What am I doing? What happens is infinitely many solutions is when you get the same number on both sides, or the identity. So basically, you get a number equals itself, which is okay. So on our last equation, we didn't get 0 equals 0, but we got 12 equals 12, right? So if I have a number and it's set equal to himself after I'm solving, my answer is infinitely many solutions, okay? So if I get a number, if I get 3 equals 3 or 4 equals 4, that's fine. It's infinitely many solutions. What this means, I could plug in any value for x and it would work. That is what's so cool about infinitely many. I don't actually have one x, I have as many x's as I want. Let's take a look at this problem. Very first thing I notice, I have two of the same things on the same side, right? So let's combine that. I got that still left over. Negative 3m plus 12m. 12 minus 3, that's 9m plus 5. Let's subtract 9m. That cancels out with negative 4. That cancels out 2, so I'm left with 5. Negative 4 equals 5. That's not right. Negative 4 doesn't equal 5. We know that that is a false statement, right? So what are we going to write for that? Well, no solutions is when you don't get the same on both sides. Kind of like when we got negative 4 equals 5. We didn't get the same on both sides. So on this last equation, we got negative 4 equals 5. That doesn't make sense. So our answer would be no solution. What this means, I can't plug in any kind of x. No m's, in our case m's, would work in that equation. I can't pick an m and it would make a true statement. That's why it's no solutions. And that's the end of our video for today. See you later, Sabers.